Hello students, I welcome you in today's session of physics. As you know very well, we had covered out most of the topics of this our chapter refraction of light at spherical surface lenses. Clear? This is chapter number 16 of your unit optics. We had covered out coordinate geometry sign convention for measuring distance in lenses, refraction at concave spherical surfaces. Clear? After that we had covered out refraction at concave convex spherical surface. Fine. Then we had covered the lenses, different types of lenses, plano-convex, concavo-convex. Clear? Now we also cover the converging and diverging action of lenses here. I hope you understand it. Some definitions, optical center. Then we cover out the focus and focal length. Fine. So now today we will starting our class from this point, because in our previous lecture I left the topic this one. So today we will start it from here. This is the part of the focal length, and you have to know where the focal length is positive and negative. So we will discuss in this section. So as the ray travelling parallel to the axis of the lens, after refraction through the lens, they either go towards a fixed point on the axis or appears to come from a point. Fine. So this point is called the second focus. I told you in our previous lecture the first focus. Now here we are discussing about the second focus. This is the figure of concave and convex lenses, and you can see here easily. Fine. So the principal focus, here you can see in the figure number 11A, this is the first figure A and this is the second figure B. The point F is the second focus of the lens. All the axial parallel rays emerging from convex lenses actually pass through F. Here you can see this is the focus, then after refraction they passing from the focus F, whether it is concave or convex. While those emerging from a concave lens appears to come from F, but if you see the concave lens, the rays appears to come from the focus F. Clear? The distance of the second focus from the optical center of the lens. Clear? You have to define the definition of second focal length. So the distance of the second focus from the optical center of the lens is called as second focal length, or you can also say it the principal focal length of the lens. Fine. So in figure 11A in 11B, the distance CF is the principal focal length of the lens. Here you can see this is the distance C to F, whether you take it in the convex lens or in concave lens. So the distance of center of curvature to the second focus is called the second focus of the lens, or you can say the principal focal length of the lens. In figure 11A and 11B, the CF is the principal focal length of the lens, as I shown you. It is clear from the figure 11A and 11B that the focus in a convex lens is real. This is the convex lens and this is your concave lens. So the focus or in convex lens is real, while in a concave lens it is virtual. So according to the sign convention, the focal length of convex lens is positive, while that of a concave lens is negative. Fine. You have to remember this, the focal length of a convex lens is taken as positive, while if you talk about the focal length of concave lens, then it is taken as negative. When the medium on both the sides of a lens is same, like such as air, then the numerical value of both the focal length of the lens are equal. In what cases? If you ask, somebody ask in which what cases the focal length is taken equal, so you have to know very well. You have to know very well that the focal length in both the cases lenses are equal, that is F is equals to minus F dash. Clear? Here you can see this is the focal length. I hope it is clear for you. Now we will talk about what is focal plane. So the plane passing through the focus of a lens and perpendicular to the principal axis is called the focal plane. Means the plane which is passing through the focus of a lens. Clear? And perpendicular to the principal axis is called the focal plane. I hope it is clear for you. Here it is a focal plane. This is the passing through the focus and perpendicular to the, this is the focal plane. Here this one dotted line you can see here, this is the dotted line which is perpendicular to the principal axis. Clear? And passing through the focus in case of concave and convex lens. This is known as focal plane. I hope you understand it very well. Now we will move to refraction of light through a thin lens. This one. This is your lens maker formula. So the lens maker formula relates the focal length of a lens, fine, to the refractive index of the material of the lens and the radii of curvature of the two surfaces of the lens. It is used to make a lens of required focal length from a glass of given refractive index, hence its name, lens maker formula. So in deriving this formula, we adopt the coordinate geometry sign convention and make the following assumption. The first one is the lens is thin so that the distance measured from the pole of its two surfaces can be taken as equal to the distance from its optical center. The second one, the aperture of the lens should be is small. The third one is the object is a point object placed on the principal axis of the lens. Clear? Now the fourth one, the incident and the refracted rays make a small angle with the principal axis. So here you can see, this is the figure given. Let us consider a convex lens made of glass of absolute refractive index how much, N2, placed in a rarer medium of absolute refractive index N1, means this is the refractive index, N1 is the refractive index of rarer medium and N2 is the refractive index of the lens which is placed in a rarer medium. So we can write here, let P1 and P2 be the poles. Here you can see P1, this point, and P2 are the poles, and C1 and C2 are the center of curvature. Here you can see C2 and C1 are the center of curvatures. So we can write here radius of curvature how much, P1 C1 is the first radii of curvature and P2 C2 is the second radii of curvature, fine. So let C be the optical center. See here you can see this is C is the optical center and T is equals to how much, P1 P2, the thickness of the lens, T total. Here you can see there is a small t given here. So P1 to P2, this is the thickness of the lens, fine. Let a point object O be placed on the principal axis. Here you can see we put a point object O on the principal axis. This is the object, point object of the lens at a distance u from the pole P1. This is the distance of object, that is u, from the pole P1. First surfaces, a ray OA travelling in the rarer medium, you can see here this is the ray OA which is travelling in a rarer medium N1 whose refractive index is how much, N1, is incident on the first surface of the lens. Here this is incident on the first surfaces of the lens, clear, and refracted into a denser medium N2 along AB. Here you can see this is the refraction is going on here, and after refraction the ray is going into the second medium whose refractive index is N1, is incident on the first surfaces of the lens, refracted into the denser medium N2 along AB, bending towards the normal. Here you can see if we draw a normal over here, this is the normal from C2, this one, and from C1 here. So it's bent towards the normal C1A N1. You can see from the figure at the point A. If the second surface of the lens were absent, then what happened in that case? The ray AV would have met the principal axis at I dash. This is the I dash you can see here. If the second surface is not present in the lens, then in that condition the ray is like to be meet at the point I dash, fine, from P1 B, which is the image of O due to the refraction at the first surface. So this is the image of the object O after refraction from the surface, clear. Now let's the distance of I dash from the P1 matlab means first distance of the I dash from the first focus or pole, this one P1 to I dash is taken as V, fine, then or you can write it V dash. Then for the refraction at the first surfaces we can write here N2 upon V dash minus N1 upon U is equals to N2 minus N1 by R1, this one. So the ray AB travelling in a medium N2 is actually incident on the second surface of the lens and is refracted into the rarer medium N1, bending away from the normal. You can see from the figure the right ray is bending away from the normal, that is C2B N2 at point B. Here you can see in the figure C2 N2B, this is the ray we are talking about, fine. So the emergent ray meets the principal axis at I, which is the final and real image of O formed by the lenses. In the figure you can easily see the real image which is formed by the emergent ray, this one. This is the real image of object O. Fine, I hope you understand it. For refraction at the second surface of the lens, I dash acts as a virtual object. Now what happened? Now this I dash acts as a virtual object for the second surface if the second surface is present there. In that case, I1 or I dash act as a virtual image. Clear? So you can write it here. For refraction at the second surfaces of the lens, I dash act as a virtual object and I is the real image of the form by these surfaces. Let us suppose V be the distance of I from the pole from where P2 of the second surfaces. So the distance of I dash object from the second surface from the pole P2 of the second surface V dash minus T. Then for refraction at the second surfaces from denser medium N2 to the rarer medium N1, we have N1 upon V minus N2 upon V dash minus T is equals to N1 minus N2 upon R2. So we can write here, if the lens is thin, means the thickness is very small, V dash can be ignored. Then what happened? N1 upon V minus N2 upon V can remove the thickness of the lens. Clear? If the lens is thickness is very small, so the formula changes to above formula N1 upon V minus N2 upon V dash is equals to N1 minus N2 by R2. Fine. Now adding equation 1 and 2. So where is the equation 1? This one is your equation number 1 and this one is your equation number 2. So when you add both the equation, what we this is the equation first. This one is your equation number 1 and the below one is the equation number 2 here, or you can assume it this is the equation number 2. So what will you get if you add both the equations 1 and 2? You get the final expression N1 upon V minus N1 upon U equals to N2 minus N1, 1 upon R1 minus 1 upon R2. Clear? Now dividing both sides by N1 we have, if we divide both the equations, this above equation by N1, this one. So we get here 1 upon V minus 1 upon U is equals to N2 upon N1 minus 1 and multiple of 1 upon R1 minus 1 upon R2. Now we are putting here N2 by N1 equals to N. Clear? So the refractive index of the material of the lens with respect to the surrounding medium, we have what we get here 1 upon V minus 1 upon U is equals to N minus 1 into 1 upon R1 minus 1 upon R2. So we can say here, when the object is at infinity, the image will be formed at the principal focus of the lens. This is the important line you have to note down. That is, when U is equals to infinity, V equals to F. Clear? Means when an object is placed at infinity, so the image formed by that object is at where? Principal focus. Fine. So therefore from equation, this is the equation number 3, we have in place of V we can write 1 upon F and in place of U we can write here 1 upon infinity. This is the thing, and remaining terms we write it as it is. So finally we get the focal length how much? 1 upon F is equals to N minus 1 upon R1 minus 1 upon R2. This is your lens maker formula. Fine. It has been derived for a convex lens forming a real image, but it can equally applicable to the convex lens also, which is forming the virtual image, and to a convex lens which forming the virtual image also. Clear? I hope you understand it. Now comparing, if we compare both the equations, so what we will get here, the finally equation number 3 and equation number 4. This is the equation 3 and this is the equation number 4. So if you compare this both the equation, finally you will get here how much? 1 upon V minus 1 upon U equals to 1 upon F. This is the final expression of the lens maker formula, and this relation is also called Gaussian form of lens equation. So you have to know very well what is the Gaussian form of a lens equation. So 1 upon V minus 1 upon U equals to 1 upon F. I hope you understand it properly. Clear? So that's all for the today's class, student, and the remaining topics we will cover out in our next lecture. Till that, do study. Thank you class. Thank you very much.